Welcome back to We Dared Chemistry. In this lecture, we will spend our brain doing some in-text questions, so join us whether you are a student or a curious mind. In-text questions. Problem 2.9. The threshold frequency nu0 for a metal is 7.0 into 10 raised to the power 14 per second. Calculate the kinetic energy of an electron emitted when radiation of frequency nu equals 1.0 into 10 raised to the power 15 per second hits the metal. We have the following given values. Threshold frequency is equal to 7.0 into 10 raised to the power 14 per second. Frequency is equal to 1.0 into 10 raised to the power 15 per second. Solution. From the previous lecture we have seen Einstein's equation. Kinetic energy is equal to 1/2 into mass of electron into square of electron's velocity is equal to Planck's constant into frequency, threshold frequency. Substituting the values in the formula, kinetic energy equals h, nu0. Kinetic energy equals 6.626 into 10 raised to the power minus 34 multiplied by 1.0 into 10 raised to the power 15 minus 7.0 into 10 raised to the power 14. After shifting the decimal, kinetic energy equals 6.626 into 10 raised to the power minus 34 multiplied by 10.0 into 10 raised to the power 14 minus 7.0 into 10 raised to the power 14. Kinetic energy equals 6.626 into 10 raised to the power minus 34 multiplied by 3 into 10 n raised to the power 14. After final calculation, kinetic energy equals 1.988 into 10 raised to the power minus 19 joules. So the kinetic energy of an electron is 1.988 times 10 raised to the power minus 19 joules. Thank you for your attention. Keep studying with We Dared Chemistry.